Show and all work, decide whether or not the listed function represents exponential growth or decay. Give the percent of growth or decay, and there's an example there. Sample answer, 42% growth. And then identify the y-intercept. And it hasn't been so long since we did this. We had like a whole page of this in our notes. So I want you to look at number 1 and tell me, is that one going to be growth or decay? Yep. 1.7, that base is what we're looking at, and that's going to be growth. Can you tell me how much growth? 70%. Good, because it's not 1 anymore. It's 1 plus 0.7, which would be 70% growth. Anybody remember the easy way to find the y-intercept? It's always 0a, and it's a point. 0.0a, 0.25. There it is. So there's not a ton of work that you could show for this one. Mostly the points will come from, did you find that it was growth or decay? Did you have the percentage right? Every once in a while somebody accidentally writes down 0.7. It said put it in percentage. Alrighty, take a look at number 2. Growth or decay? Decay. This number is a fraction, a decimal between 0 and 1, so this is decay. And now this is the one where you might need to grab a calculator. You can think, well, it was 1 minus something. So if I have 56 cents left, how much did they take from my dollar? You could use algebra to solve it too. You could subtract a 1 from both sides, divide by a -1, whatever you have to do, but that's going to be 44% decay. The y-intercept is the ordered pair what? Zero 4, because it's 0a. Number 3 is a trick question. Notice anything weird about number 3? They were hoping we'd miss that. That is not simplified, so we can't tell them growth or decay until we simplify this. What does a negative power do? That changes everything. Doesn't it? So is this growth or is it decay? It is decay. That's a fraction between 0 and 1. So we had 1 minus something gives you 1/8. Well, if you have 1 of something, don't you have 8/8? So if there's only 1/8 left, how many did they take away from 8/8? 7/8. And it is supposed to be as a percentage, so we'd want to grab a calculator and figure out what's 7 divided by 8. Put my marker down. 0.875. So as a percent, that would be 87.5. Zero what for this one? Yeah, the negative exponent didn't affect the a value out there, the 15, at all. So we're going to have to be careful. Always check, did they leave a negative exponent, hoping that we would miss that. Simplify it before you start talking about growth and decay. Piece of cake tomorrow? Good. Describe how the graph of each function is related to the graph of its parent function, then graph it. Show the parent function graph, that's what we normally do, the shape graph, and shift it appropriately. Absolutely, that's what we do, that's what we've always done. So it's almost like you're getting a big hint as you work through this. List, domain, range, and asymptote. We'll worry about all that as we start our work here. What do we use for our table? How far do we go with this y equals negative of 3 to the x plus 2? for our table. We just take A. So we stop as soon as we get to the x. That's what we're going to put in our table. Right there. Now, it said, describe how the graph of each function is related to the graph of its parent function. Remember, our parent function is already going to have, and that negative didn't show up very clearly, is already going to have the negative in there. So all we should be telling them for description is this far right and left, this far up and down. That's all we should be telling them. So reminder here that that's what our generic formula looks like. Y equals A times B to the x minus h quantity, and that should be in parentheses, plus K. So how will we move this graph? Right, left, up, down, and how many? Left 2? Up 2? Everybody's quiet today. Up 2, exactly, you got it. Because this is not in parentheses with our power. Yeah, you got it. Just not hearing from enough people today. So once we get our table done and we graph our parent, all we're going to have to do is move that up 2. Question is, what kind of numbers should we use in our table? So I start thinking, well, if I put negatives in here, that's going to flip that, and that's going to give me fractions. I don't need a lot of fractions because I know where it's going. So I think I'll just put -1 in. And then I think about 3 squared is 9. I'm graphing -10 to 10. That's probably all I'm going to be able to fit in there anyway, so why not stop at the 2? So we raise it to the -1 power, which flips it and makes it -1/3. Anything to the 0 power is 1, so it's going to be a -1. Because remember, after we raise it to a power, we still have to multiply it by -1 out in front. 3 to the first is 3 times -1 is -3. 3 squared is 9. 9 times -1 is -9. This is our parent. This is dashed or dotted, not solid. So carefully put that one on there. Can't even see the lines. We'll go hopefully about there. So hopefully this reminds you the x-axis is our asymptote when we don't have an h or a k shift. But we did have a k shift. And that means we have to move this up too, which means our asymptote is going to move. And part of graphing these is putting on the new asymptote. So the new asymptote will be up here at y equals 2, because we have to move all of this up 2. Anybody concerned that that one went downward? What told us it was going to do that? Exactly. So we shouldn't be concerned about that. Now let's just take our 4 very nice points and move each of them 2 up. Use a different color here. They do continue on forever, so make sure you have arrows going in both directions, and make sure it does not look like you're going to cross that asymptote. Johan, you don't have the big pile of stuff. Okay. We took care of all that before you got here. There you go. All right, back to it. Domain. Right and left, is this thing going to stop? Got arrows, right? I mean, even though you're kind of like, well, it's almost going straight down, it's not going straight down. It's going right and left forever. So the domain, all reals. But we definitely had a cutoff for the y's. What's the cutoff? The 2. And it can't be 2 because 2 is an asymptote, so no equals bar this time. Are we above it or below it? So it needs to be less than. And then, of course, we'll put our asymptote on there. And then, always a good idea, read the question one more time. Make sure you did all the A, B, C, and D's that it said to do. Describe how the graph of each function is related to the graph of its parent function. Well, that was our up 2. Graph it. Did that. Show the parent function graph, then shift it appropriately. Of course, that's how we graph them. List domain, range, and asymptote. Check. We got it all. Let's go to this one. Same directions. Y equals 8 times 1/4 to the x minus 2. So let's first go over here. What are we going to use for the table? What part of all of this do we use that table for? Yep, stop right after the x. Even if there was something behind it, we stop right after the x. Y equals 8 times 1/4 to the x. So after we get all our numbers for that, and we make our parent function on the graph, where are we going to move it? Yep. 2 down. And we can wait to talk about domain, range, and asymptote until we do all that stuff. So, wow, that's got an 8, huh? That's a big number in front there. So let's start thinking about what's going to happen with this. First, is this growth or decay? It is decay. So it's going to start high, and then it's going to go low. So I need a few more negatives this time and not so many positives. I might put 2 on there. Wait and see. Let's see what we get. Alrighty, with a negative 2 up there, we're going to see we have to flip it, which makes it 4, square it, which is 16. 16 times 8, wowzers. I don't know about you, but I don't see 128 up there anywhere. Give me something to aim at. Negative 1, flip it, it becomes 4. 4 times 8, still not something that's going to be on my graph. Hopefully we'll get 1 soon. Put a 0 in there. What's 1/4 to the 0? 1. What's 1 times 8? Finally, something that'll fit. And we put a 1 in. And remember, 8 is the same thing as 8 over 1. You can just do top times top, bottom times bottom, and then reduce if you want to, but that's going to be 8/4, which is 2. And I'm not seeing a fraction yet, so I'm going to keep going until I get a fraction. I'll put a 2 in. So with 1/4 squared, what we have to do is square both the numerator and the denominator. So that's going to give us 1/16, or you use your graphing calculator and you just punch it in. You know, that's what most people will probably do anyway. But 1/16 times 8 over 1 will be 8/16, which is 1/2. So notice I just kept going until I had something that was a fraction, so I knew that it was going to be decay and it was getting closer and closer to the x-axis. But we can't graph a whole lot of these. I mean, we're going to be able to graph 0, 8, 1, 2, and 2, 1/2. But that's really enough. So we can see, yes, this is decay. Don't make it look like an L. It's not an L. It's supposed to have a gradual curve. And we even need arrows on our parent function. You know, our parent function without that 2 down, it would be going on forever. So where's our new asymptote going to be at if we have to move the whole thing 2 down? Yeah, -2. Y equals -2. Might as well put that in the slot. So all we have to do is take our parent function and move it 2 units down. Oops. Again, we know this one is really steep, so we want to make it look like it almost goes straight up and down as we're going to -132 and -2, 128. Very, very steep because of that 8. So what's our domain on this one? Yeah, we can use any x's we want. Definitely can't use any y's. You told me the cutoff was -2, right? Can't use equal to. Asymptotes, it approaches, it never touches. So what should we put in between those two? Yep, it's above it. Good. We did everything they asked us to do. It's all there. Finally, one with both an h and a k. We need to see all of it. So describe how the directions are exactly the same. Describe how the graph of each function is related to the graph of its parent function, then graph it. Show the parent function graph, shift it appropriately, list the domain, range, and asymptote. So help me out here. For my table, what do I want to take? Y equals 3 to the x. That's it. H and k, wait until we move it. So where will we move this one? Be careful, remember about x. It's the naughty variable. 2 left and 4 down. So a little bit more to keep track of this time. We go over to our table. Growth or decay? Growth. So 1 or 2 negatives is probably all we need. I mean, it's just a 3. Maybe -1, 0, 1, 2. If we know it's growth, we know it's going to start low and it's going to go high. Negative powers do what again? Flip it. So this will become 1/3. Anything to the 0 power is what? 1. 3 to the first is 3, and 3 squared is 9. There's our parent function. Let's get it on there. So now this problem is really to see, do we know if it's the h or the k that affects the asymptote? And can we get all of that on there right? Where's our new asymptote going to be? Exactly. H has nothing to do with the asymptote, just k does. So y equals -4. And it needs to be an equation for a line, so we have to put the y equals -4 piece on there. That y equals says, hey, this is a horizontal line. Well, now we have to move it. Good news is we just have 4 little points to move. So each of those needs to go 2 to the left and 4 down. Don't let it cross the asymptote. That's a big no-no. That says we don't understand what asymptotes are. Lines it approaches, but never crosses. So what do you suppose the domain is for this one? Use whatever x's you want. Do we have a cutoff for the y's? Got -4. Above it or below it? Using the greater than. Whew. 3 graphs tomorrow? Everybody feeling okay with graphing? Okay, asymptote is controlled by K. That's what we have to watch out for. Well, there's more to this test, because we did a lot with interest over these last few days. So we've got 5 problems on here that deal with interest. And you are going to be given these formulas. Thing is, you have to know which one gets used for what. So I'm going to go over that real quick again. Now, this isn't exactly like the books because it doesn't have a of t. They just did y instead. But this is our exponential growth model, which we use for simple interest, when interest is only once a year. That's the top one. So this is simple interest. So when they just say annual interest, that's the one we use. The second formula, wow, we should notice the difference between that and all the other formulas up here. That has subtraction, and that's because this one is depreciation. This is where it's going to go down. It's exponential decay. So this will be any problem where they say we need to depreciate blah, blah, blah. Now we had another specialty formula, so I'm going to skip this one and go down to stinky green shampoo. This one, we have to see the words continuously compounded. Continuous. Seem to have too many U's there. Continuously. There it is. Compounded continuously or continuously compounded. We have to use the stinky green shampoo formula. APERT. Everything else is this bugger. So this one is just called the compound interest formula. If it's compounded semi-annually, if it's compounded quarterly, monthly, daily, that one takes care of all of that. And I warned you when we went through this yesterday, people forget that there's an n in 2 spots. Don't forget that n is there twice, because you're going to get totally the wrong answer and wonder what on earth did I do when you see that you didn't get a perfect score. All right, are we ready? I can scroll back if you need after we start working on these. First thing we do is read through the problem to figure out which formula we should be using. You purchase a new car for $33,000. Your car depreciates at a rate of 14% per year. What is the value of your car after 10 years? What formula are we going to use? The one with subtraction, right? It's depreciation. That's that one. So lowercase a is lowercase a for a reason. It's supposed to make you feel like it starts the alphabet. So that's what it started at. How much did you pay for the car? 33 grand. 1 is part of the formula. Interest rate is a decimal. 0.14, 0.14. How many years? So like I said when we were covering this yesterday, here's 1 point. I picked the right formula. 2 points. I put them in the right way, including I moved the decimal over 2 spots. Third one, can you punch it in right? So you might want to do $1 minus 14 cents first, just to make it a little bit easier to punch in. $1 minus 14 cents is how much? 86 cents. I'm going to run out of space here. You know what? I'll make a box for my answer. 33,000, 0.86 to the 10th. Again, we're just going to round dollars and cents. So $7,302.95. There's our answer. So there's the third point. Can you punch it into the calculator right? To get the answer. So depreciation, only formula that has a minus in it. That's it. Number 8, the population of Math Town is 72,000. The population is increasing by 22% each year. What will the population be in 15 years? Which formula? Top one, basic one? Okay, simple interest. Obviously, we started at 72,000 peoples. 1 plus, what do you do with that interest rate to put it in here? 0.22. Did they say how many years? 15. Again, you could do the 1 plus 0.22 in your noggin just to make it a little bit easier to punch in. And again, I ran out of room. But this one is people, and you can't have a half a people, so we're going to have to round to the nearest people. $1,421,445 people. It's a lot of people. Does that seem like a lot? So you want to think when you're done. Yeah, is my answer making sense for what's going on? Remember, it was growing at 22% each year. So it should be getting pretty big pretty fast. And we did 15 years, for goodness sake. Yeah, a big number makes sense here. So you just stop and figure out, did I do something wrong, or is this a good answer? Number 9, a parent increases a child's allowance by 10% each year. If the allowance is $5 now, when will it reach $12? Formula. Simple interest, once a year. Okay, simple interest it is. So they're starting with a little $5. What do I put in for R? 0.1. How many years? Oh yeah, we don't know that, do we? What are they hoping to get to? 12. So we can simplify that to 1.1 to the x, but I don't think we can do that with algebra. How do we do that? Graphing calculator. Yep, we do the old y sub 1 and y sub 2. And it really doesn't matter which one is y sub 1, y sub 2, but I usually pick the one that's a little more involved for my y sub 1. All right, graphing calculator, we need you. Y equals 5 parentheses 1.1 parentheses to the x. And we need to find out when that's going to be 12 bucks. Now I definitely need your help. I want to be able to see this, so it's window time. Obviously, we're going to start at 0 years. So let's just throw a guess out there. How many years do you think it'll take if they're increasing it by 10% each year to get to that 12? Try 0 to 10? We'll try that. If it's not enough, we can come back and fix it. And what do we have to be able to see? 12. So maybe 0 to 15 for the y's. Looks like we got it. Under 10. But we want to find it. So how do we find it? Second trace. Which one? Yeah, Blinky's going to help us out. And if this is the only two that you have in y sub 1 and y sub 2, you can just hit enter 3 times. Blinky says about 9.2 years. Now, with this one, you start to think, well, if it were a bank, we would round it up and say they have to wait till 10 years. But this is somebody's parents. I mean, if the child goes up and says, well, could you just increase it a little bit more? Yeah, they're probably going to do that at some point. So we'll just leave it at 9.2. This is not a bank. 2 more to go. Just 2. Here they are again. There are our lovely formulas. Your grandparents invest $82,000. Wow. When you are born for your college fund, good for them. The account pays, oh boy, yeah, there's the bad news, 1.5% interest. But it's compounded monthly. How much will you have when you graduate from high school 18 years later? Formula. Yeah, our big compound interest formula from yesterday, the big formula. All right, so let's see what we know. We know they put $82,000 in. We know the interest rate, so 1 plus, now here's where you have to be really careful. What will we put in for 1.5? Good, 0.015. We still have to do those 2 decimals. Every year somebody messes that up. How often was this going to be compounded? Monthly. So how many times is that? 12. And don't forget to put that in 2 spots. How many years are we looking for? 18. So again, I don't like handing things over to the calculator. I just use the order of operations to punch this in myself. I'm going to start here, then I'm going to add 1, then I'm going to raise it to the 12 times 18 power, and finally multiply it by the 82,000. All right, calculator, let's get this thing off of here, whatever it is. It won't let me. Fine. There it went. Parentheses 0.015 divided by 12 plus 1. Enter. To the 12 times 18 power times 82,000. That's some good money. We have $107,398.97. That may just pay for your college. $107,398.97. That just may do it. More involved formula, more compounding taking place. All right, number 11. We should know which formula we're going to have to use because there's one we haven't used yet, right? You put $4,000 into an account earning 2.5% interest compounded continuously. Find the amount in the account at the end of 10 years. It said compounded continuously. Which one is that? The one with E, the stinky green shampoo formula, the PERT. All right, how much did they put in? $4,000. E's a number in our calculator. We're going to punch that in. R as a decimal, be careful. 0.025. How long? 10 years. Again, you could punch it in just as it is, or you could do this 0.025 times 10 in your head and get 0.25, whatever you want to do. But we have to punch that in and get the right answer. So that means e to the power is on here somewhere. Are we remembering where it is? Good. Second ln. There it is. 0.025 times 10. Oops, this one doesn't use parentheses. $5,136.10. This is a test with different numbers on it. So, anybody have a question? Do you have one of these where you're like, oh, Cedar Home, would you make another one of those? Because I'd really like to see one or try one. Well, that's what the review's for then. So, the review assignment, which I think I already got to everybody here, or if you can't find it, they're on Schoology. So, Google Meters, it's a white sheet of paper, says Algebra 2 review assignment. Let me show you where it is. Anything that we copy is always going to be in that black folder. Digital copies of worksheets and handouts. And then you can just look for the date. So here it is right here, March 24th, right after the practice test. And it has the assignment listed at the top, if it ever comes up. It's trying. There it is. So the assignment's listed at the top here. And then obviously we've got our 1 through 6 here that are interest formulas to get you ready for those, for the test tomorrow. So we should be set. I'm going to turn the lights up. And you can start working on your review. And I can wander around and help anybody. Is there anybody that still needs the review assignment that I have more copies of here? Yes, you're welcome.